Hi class, in this lecture we continue our study in chapter 12 by moving into section 12.4 where we're going to talk about something called the cross product. Okay, so what exactly is the cross product? So suppose you're given two non-zero vectors. So we have vector A, which is a three-dimensional vector, and vector B, which is also a three-dimensional vector. All right, it's going to be very useful to be able to find some non-zero vector we're going to denote as C that's going to be perpendicular to both A and B. Okay, so how are we going to find this vector? So we want another vector C that's a three-dimensional vector. And we know that from our previous lectures that a vector is perpendicular to another vector if their dot product is equal to 0. So we want to find a vector C such that when you take its dot product with A and at the same time you take its dot product with B, both of those equal 0. So basically we're trying to solve for C1, C2, C3 in these two equations simultaneously. Okay, how are we going to do that? Well, this is where we introduce what's called the cross product, and it goes like this. If vector A is a three-dimensional vector and vector B is also a three-dimensional vector, then the cross product of A and B is in itself a vector, and it's denoted as A and then with this sign X here, B. What this is read as is A cross product with B, okay, or the cross product of A and B. This does not mean multiply. This is basically the equation for it, and I'll try to explain where this equation comes from in the coming slides. But all you're really going to do is this part here is the first component of vector C, this is the second component of vector C, and this is the third component of vector C. Okay, so notice that the cross product of the two vectors, unlike the dot product, is a vector itself. Like the dot product is just some scalar product or inner product. This is why we sometimes also call the cross product the vector product. And note that this cross product is defined only when the two vectors A and B are three-dimensional vectors. Okay, so how are we going to do these formulas very, very simply? I'm going to show you a method using matrices and determinants, or you can also just have this formula handy and just directly go, okay, how do I find the first component? Well, I take A2, multiply it by B3, then I subtract the A3 multiplied by B2. Okay, but in order to make this easier to remember or easier to complete, we're going to use this notion of determinants. So I want to show you or remind you how to find the determinant of order 2 matrix, so a 2 by 2 matrix. So we have this matrix that goes A, B, C, D. Now the determinant of it is just a number, okay? And this is always the formula from it. You take A multiplied by D, and then you subtract B multiplied by C, always. So if, for example, suppose you have this 2 by 2 matrix here, okay? It's 2, 1, negative 6, 4. The determinant of this, you take 2, multiply it by 4, and you subtract 1 multiplied by negative 6. Well, negative is a positive. You get 8 plus 6, gets you that 14. So doing determinants for 2 by 2 matrices are pretty straightforward. Okay. Now, the next part. So how do you find the determinant of an order 3 matrix? So a 3 by 3 matrix, okay? So this can be defined in terms of a second order determinant as the following. Okay, so you're going to put A1, A2, A3 up here, B1, B2, B3 here, and C1, C2, C3, always in this order, okay? You're going to start in the upper left here. You're going to take A1. And then what you're going to do is you're going to cover up the row and the column that A1 is in. So you're going to take A1, you're going to put it here, and after you cover up the column, the row and the column, you're going to be left right here with this little 2 by 2 matrix. So you have B2, B3, C2, C3. And then what you're going to do is you're going to find the determinant of that right here. Next, you're going to subtract. This is important. You subtract, you go to A2, and you cover up the row it's in and the column it's in. And when you cover up that, what you're left with is B1, B3, C1, C3. And you take minus A2 and multiply it by the determinant of that resulting 2 by 2 matrix. Now you go plus A3, so you go to A3. Cover up the row A3 is in, you cover up the column A3 is in, and you're left with this little 2 by 2 matrix B1, B2, C1, C2. And you multiply A3 by the determinant of that 2 by 2 matrix. All right, so observe that each term on the right-hand side of equation 5 involves a number AI, A1, A2, A3. In the first row of the determinant, And AI is multiplied by the second order determinant right here, right here, right here, obtained from the left-hand side by deleting the row and column in which AI appears, which is what I just walked you right through. All right, also notice, just really important, that the middle term is subtraction and the third term is addition. All right, so let me walk you through how you find the determinant of this 3 by 3 matrix here. So you have 1, 2, -1, 3, 0, 1, -5, 4, 2. Okay, so this is my A1. This is the top value. So I'm going to take 1, and I'm going to multiply it by the resulting 2 by 2 matrix when I cover up the row and column 1 is in. So I need to multiply it by the determinant of this. Then I go minus, because it's the second part, minus 2. I'm going to cover up the row and the column, and I'm left with 3, 1, -5, 2. So I need to find the determinant of that. Then I go plus my minus 1, covering up this, and I have this little 2 by 2 matrix, 3, 0, -5, 4 left. So then I find the determinant of this, which ends up being 0 minus 4. Here it ends up being 6 plus 5 because of the minus. Here it ends up being 12 minus 0. And then you just do a little bit of arithmetic here, and the determinant ends up being -38. All right, so how are we going to do this for the cross product? So now if we write the definition we had at the start of this lecture using second order determinants and the standard basis vectors I, j, and k, we see that the cross product of these vectors, vector A is equal to A1 times I plus A2 times j plus A3 times k, and vector B is B1I plus B2j plus B3k. So then the dot product, the cross product, A cross product with B, just replacing the values of A1, A2, and A3 with I, J, and K, we have the following. Okay, going back to the formula here, A2, B3 minus A3, B2, A2, B3 minus A3, B2, I, see it? And you get the same with the others. All right, so in view of the similarity between equations 5 and 6, what we can do is we can now write the cross product as the following. Okay, A cross product with B, replacing the A column here, A row, with I, J, K, and then the components of each of the vectors, A1, A2, A3, B1, B2, B3. We can use this determinant of this 3 by 3 matrix to find the cross product very, very easily. Okay, let's do one example. So I have this vector here. Vector A is equal to 1, 3, 4, and vector B is equal to 2, 7, -5. Then what I want to do is I want to find their cross product. All right, so to do the cross product, what you do in the first row, you put the I, J, K, all right, for the vectors. Second row, you put vector A, which is 1, 3, 4, and then in the final row, you put vector B, 2, 7, -5 right here. Then you just go through the determinant of a 3 by 3 matrix. Take the first row, first component here, I. You cover up the row and the column. This right here, 3, 4, 7, -5, is the resulting 2 by 2 matrix. You go to J, cover up the row and column J is in. 1, 4, 2, -5 is the resulting 2 by 2 matrix. K, cover up the row and column K is in. Then you're left with 1, 3, 2, 7. You find the determinant of that resulting 2 by 2 matrix. You can go through the arithmetic here. 3 times -5 is -15. Minus 4 times 7 is 28. And you can do that for all the components I, J, and K. And this, once you clean this up, this vector here, minus 43I plus 13J plus K, is the cross product of the vectors A and B. It is the vector that is perpendicular to both this vector and this vector here.